Hello everyone, I welcome you all for SVK tutorials. In this video, I am going to continue the solutions of Model Question Paper 1 for the first semester BE degree examination, Mathematics 1 for Electrical and Electronics Engineering stream. So as I have discussed earlier, Module 1 and Module 2 with complete solution. So I will be discussing the Module 3. I am going to provide the complete solution and how to solve all the problems of ordinary differential equation. I am going to explain in this video. So Module 3 is of question number 5 and 6. I will be discussing question number 5 and 6. Moving on to the solution. So Module 3, I have taken question number 5a, solve. So mainly all problems will be given in terms of solve itself. So solve x into dy by dx plus y equal to x cube into y power 6. So you require to analyze here which type of problems here. So you have methods of solving a differential equation. You need to recognize the problem of the form. So it is an linear differential equation. So I am going to divide the term by x into y power 6. So I am going to get, so after dividing x into y power 6 for the given equation, I am going to get 1 over y power 6 into dy by dx plus 1 by x into y power 4, which is equal to x square. So I am going with the substitution, put t equal to 1 over y power 5. So if I go with the substitution, I am going to get minus 5 by, since derivative of 1 over y power 5 is 5 minus 5 by y power 6 into dy by dx, which is equal to dt by dx. So we have extra term as minus 5. So divide by minus 5 on both the side. I am going to get 1 over y power 6 into dy by dx as minus 1 over 5 into dt by dx. So go with the substitution of this in the above expression. I am going to get minus 1 by 5 into dt by dx plus t by x, which is equal to x square. So multiply throughout by minus 5. I am going to get dt by dx plus of minus 5t by x, which is equal to minus 5x square. So then we can say that this equation is a linear differential equation of the form dt by dx plus pt equal to q, where p is what? Just compare the p here. Here coefficient of t is, now the differential equation is in terms of dt by dx. So therefore the coefficient of t is minus 5 by x, that is what p, and the q term is minus 5x square. So note downing the value of p and q. Then we are going to find out integrating factor. Integrating factor is given by e power integral of p dx. So integrating p value, we are going to get integral of 1 by x is log x, which is multiplied by minus 5. So which is nothing but, as we have apply the loss of logarithm here, which can be written as log x whole power minus 5. Applying a loss of logarithm here, we can write this as e power log of x power minus 5. Here base c is there. So applying loss of exponential, loss of indices, we are going to get x power is nothing but 1 over x power 5. So that is what the integrating factor we got. Then the solution of the given differential equation of this form can be written as t into integrating factor, which is equal to integral of q into integrating factor with respect to x plus c. So t into integrating factor is 1 by x power 5, which is equal to integral of minus 5 into x square, which is multiplied by integrating factor as 1 over x power 5 dx. So here by cancellation law, here x power 2 into x power 5, x square get cancelled. You are left out with x cube here. So 1 over x cube multiplied by negative sign. So integrating 1 over x cube, integral of, you should know what is integral of 1 over x power n dx is nothing but integral of 1 over x power n dx is nothing but x power minus n plus 1 divided by minus n plus 1. So having this value, integral of 1 over x cube is nothing but we are going to get x square by minus 2. So therefore minus minus get cancelled. The final answer is 5 by 2 x square plus c is the required solution for the given differential equation. Moving on to question number 5b. Find the orthogonal trajectories. Find the orthogonal trajectories of the family of curves x square by a square plus y square by b square plus lambda equal to 1. Consider the given problem as it is x square by a square plus y square by b square plus lambda equal to 1. Name that as equation 1. Then differentiate this equation 1 with respect to x. So derivative of x square is 2x plus derivative of y square is 2y into dy by dx, that is y dash or y1. dy by dx is nothing but which is equal to y1. We are representing dy by dx as y1. So which is equal to 0. Differentiation of 1 is 0. So therefore divide on both the side by 2. So we are going to get x by a square which is equal to, I am shifting this derivative to the right hand side, which will be equal to minus y1 divided by b square plus lambda. Name that as equation 2. So from equation 1 we can write y square by b square plus lambda as either we can shift this term to right hand side or else we can shift the another terms to right hand side. I am shifting this term to right hand side here. So you are left out with x square by a square minus 1 which is equal to y square by minus y square by b square plus lambda. So taking LCM in the left hand side, I am going to get x square minus y a square by a square which is equal to minus y square by b square plus lambda. Name that as equation 3. Now dividing equation 2 and equation 3 we are going to get as here in the right hand side of both the equation we have a common term called y by b square plus lambda. It can be cancelled. So you are left out with here y a square x square get cancelled, a square get cancelled. You are left out with x by x square minus a square, minus minus get cancelled. So therefore you are left out with y1 by y, y1 by y. This is what the left out term. Now replacing dy by dx by minus dx by dy. This is what the method of solving the orthogonal trajectory. You are required to replace dy by dx by minus dx by dy. Once you got the standard form of y dash, we can replace y dash by minus 1 over y dash. So which is nothing but x by x square minus a square which is equal to 1 over y into minus dx by dy. Now separate the variables. After separating the variables, differentiate with respect to that variable. We are going to get integral of y dy which is equal to minus integral of x into dx plus a square integral of dx by x plus c integral constant. So therefore integral of y is known for us, that is y square by 2. Here integral of x is x square by 2. Integral of 1 over x is log x. Then we have a common term called in the denominator 2. Multiply throughout by 2. We are going to get the required result as x square plus y square minus 2a square log x minus b, which is nothing but minus b is nothing but 2c, that is constant, which is equal to 0 is the required orthogonal trajectory for the given problem. Moving on to question number 5c, which is a problem on solvable for p. So solve xy p square minus x square plus y square on p plus xy equal to 0. So solve for p. We are going to get p equal to, I am going to apply a standard quadratic equation, solve for quadratic equation, as we know that ax square plus bx plus c is equal to 0. When this is a quadratic equation, then solve for x is nothing but what? Minus b plus or minus square root of b square minus 4ac divided by 2a. Using this formula here, we are going to get p equal to, here the b value is this and a value is this and c value is this. Therefore b is negative here, therefore negative into negative becomes positive times of x square plus y square plus or minus square root of x square plus y square the whole square minus 4x square y square divided by 2xy. Simplifying further, I am going to get x square plus y square plus or minus x square minus y square divided by 2xy. Now splitting these two terms, we are going to get one. First I am going to take with positive sign, then I am going to take with negative sign. When I take positive sign, here y square get cancelled. When I take negative term here, I am going to get x square get cancelled. So that is what I have taken. P will be equal to, when I left out with x square term, x square plus x square becomes 2 times of x square divided by 2xy. So it will be x by y. When I take negative term, we will be left out with y square, 2y square divided by 2xy. So 2y get cancelled. You are left out with y by x when it is negative. So now separating the variables, we are going to get dy by dx equal to x by y. Now after separating the variables, we are going to get the result as x square minus y square, which is equal to 2k, which is nothing but c. So this is what after integration. So similarly for another equation, we are going to get dy by dx equal to y by x, which is implies that after separable variable separable and integrating that, I am going to get log of y by x equal to log c. Then by cancellation of logarithm, we are going to get y minus xc, which is equal to 0. Thus the general solution is product of these two. Product of these two will be the general solution. So multiplying those two terms, I am going to get the general solution for the required D. Moving on to question number 6a, which is of choice question. Solve the given differential equation x square plus y square plus x on dx plus of xy dy equal to 0. So it is of the form m dx plus n dy. So therefore we can recognize what is m, what is n. So after recognizing m and n, differentiate m with partially with respect to y and n partially with respect to x. So we are going to get partial derivative of m with respect to y as 2y and partial derivative of n with respect to x as y. So as it is, del m by del y is not equal to del n by del x. So therefore we say that which is not exact. So for that reason, we are going to take the difference of those two partial derivatives, del m by del y minus del n by del x, which is nothing but 2y minus y, which is equal to y we got. So this y value is nearest to n. So as the difference is nearest to n, we are going to divide this difference by n. So we are going to get now 1 over n into del m by del y minus del n by del x, which is equal to 1 over x. So which is nothing but, as it is a function of x, I am going to denote that as f of x. So we got 1 by x means, so the n value is 1 over n value is xy divided by xy here, xy into difference is y. So here y get cancelled, which is nothing but 1 by x. Now we are going to find out the integrating factor. Hence the integrating factor is e power integral of f of x dx, which is equal to e power integral of 1 over x dx. 1 over x integration is log x, as the base here e, and here the log function is natural log. Therefore applying loss of indices, we are going to get the value as x here. Multiplying this integrating factor to the given differential equation, we are going to get m value as x cube plus xy square plus x square and n value as x square y. Now differentiating m partially with respect to y and n partially with respect to x, we are going to get these two are equal. Therefore we can have the solution in terms of exact, which is integral of m dx plus integral of n of y dy, which is equal to c. Thus integrating m partially with integrating m with respect to x, integral of x cube is x power 4 by 4 plus y square into integral of x is x square by 2 plus integral of x square is x cube by 3, and terms containing y alone. N of y means terms containing y alone. Here there is a term called x here. There is no terms called y alone. That's why it is 0. Integral of 0 with respect to y is y into 0. Therefore it is 0. So you are left out with the answer as x power 4 by 4 plus x square y square by 2 plus x cube by 3. equal to C is the required solution for the given D. Next, moving on to question number 6b, show that a differential equation for the current I in an electrical circuit containing an induction L and resistance R in series and acted by an electromotive force E sin omega t satisfies the equation di by dt plus Ri equal to E sin omega t. Find the value of the current at any time t. We are required to find out I at any time t if initially there is no current in the circuit. So initially, with using initial condition, we should require to solve this problem. So the given differential equation, note down that given differential equation, or the problem can also be given as L into di by dt plus Ri equal to E sin omega t. This is an alternate problem I have defined here. So you can go through this problem also. So now it is of the form, the given differential equation, the given D LR circuit is of the form dy by dx plus py equal to q. Identifying what is p and identifying what is q, we have written what is p here, p equal to r and q equal to E sin omega t. So then after coming to know what is p, find out integrating factor. So e power integral of p dx is e power integral of r dt. So integral of r with respect to dt is rt. E power rt is the integrating factor. Now we know the solution for this, y into integrating factor, which is equal to integral of q into integrating factor with respect to y plus c. We are going to get I e power rt, which is equal to integral of E sin omega t e power rt dt plus c. So which is nothing but E into integral of, as it is E is a constant term, we can take out that outside, integral of e power rt sin omega t dt plus c. So to integrate this, we can have a standard integral formula. Integral of e power at into sin bt dt is nothing but e power at divided by square root of a square plus b square into sin bt minus tan inverse of b by a. Now identifying the value of a and b, a is equal to r and b is equal to omega. So therefore I into e power rt, which is equal to e into e power rt divided by square root of r square. Since a value is r and b value is omega, r square plus omega square times of sine of omega t minus tan inverse of omega by r plus c. So divide by e power rt on both the side. We are going to get these two terms get cancelled. Therefore we are left out with I equal to e times of e by square root of r square plus omega square sine of omega t minus tan inverse of omega by r. Now for our convenience, I am going with a substitution. Let tan inverse of omega by r equal to phi. So that becomes tan phi equal to omega by r. So I equal to e by square root of r square plus omega square sine of omega t minus phi plus c times of e power minus rt, as we have divided by e power rt. Now using the initial condition, as the initial condition is current is 0 at time 0. So therefore I equal to 0 when t equal to 0 in equation star in the above equation. We are going to get 0 equal to e by square root of r square plus omega square sine of minus phi plus c. Sine of minus phi is what? Minus sine phi. So therefore we are left out with shifting that negative sign to right hand side. We are left out with c equal to e sine phi divided by square root of r square plus omega square. Substitute this c value in the equation star. We are going to get I equal to e sine omega t minus phi divided by square root of r square plus omega square. In place of c, I am substituting that value. We are going to get e sine phi divided by square root of r square plus omega square e power minus rt. Taking out this common term here, e by square root of x square root of r square plus omega square. We are left out with sine omega t minus phi plus e power minus rt sine phi. So this is the required solution for the LR circuit. Moving on to question number 6c. find the general solution of the equation px minus y into py plus x equal to a square p by reducing into Clairaut's equation by taking the substitution as x equal to x square, y equal to y square. So by considering the given substitution x equal to x square, find out dx by dx which is equal to 2x, and y equal to y square, that derivative will be dy by dy will be equal to 2y. So then we are going to find out p. Small p is nothing but dy by dx which is equal to dy by capital dy into capital D into capital pi by dx, which is multiplied by dx by x dx by dx, which is equal to 1 over 2y into capital P, where capital P is nothing but dy capital Y divided by d capital X into 2x. Here 2 get cancelled. You are left out with x by y into capital P. So therefore, in terms of capital X and capital Y, we know that given small x can be written as root of capital X and small y can be written as root of capital Y. So simplifying that, small p will be equal to square root of x by y capital P. Substituting this value in the given expression, we are going to get this expression. So simplifying further, I am going to get this expression. Then I am going to make this problem in standard form, y equal to px plus f of p. This is what the standard form. Then replace p by c, we are going to get the required result, that will be the Clairaut's d. So this is what the Clairaut's d. Now the general solution for this is y equal to cx minus 2 c by c plus 1. As we know that capital Y is nothing but small y square and capital X is nothing but x square. Replacing that value, it will be y square equal to cx square minus 2c by c plus 1 is the required solution. So this is the way to solve the Clairaut's d, and this is what I have explained for module 3. And if you have any doubts in this module, you can put a comment. If you like this video, do subscribe to my channel and press like button. Thank you all for watching this video.